Okay, guys, so here's our first uh, video today. We're going to be getting into probability. So this first video is going to be a little bit longer just because it's like our quick little intro um, at the beginning. But then the next two videos following up will be probably about half the size. So this one might be 10 minutes or so, but the next one should be closer to like 5. Okay, so for the beginning, we will discuss just the very simple idea of probability. Not much new here, so very much the same idea of probability that you have seen in the past. So, quick little intro into probability and what we'll be doing with it. So, really, guys, what we're focusing on is the idea of chance, and chance is all around us. So, you and your friend play rock, paper, scissors to determine who gets the last slice of pizza. A coin toss decides which team gets to receive the ball first in a football game. Many adults regularly play the lottery, hoping to win a big jackpot with a few lucky numbers. Others head to casinos or racetracks, hoping that some combination of luck and skill will pay off. People young and old play games of chance involving cards or dice or spinners. The traits that children inherit: gender, hair and eye color, blood type, handedness, dimples, whether they can roll their tongues, are determined by the chance involved in which gene gets passed along by their parents. So, a roll of a die, a simple random sample, and even genetic inheritance represent chance behavior that we can understand and work with. We can roll the die again and again and again. The outcomes are governed by chance. But in many repetitions, a pattern will start to emerge. So we can use mathematics to understand that regular pattern of chance behavior when we repeat the same chance process again and again. And this would be called probability. Okay, so things that involve probability might be something like tossing a coin 10 times. How likely are you to get a run of 3 or more consecutive heads or tails? An airline knows that a certain percent of customers who purchase tickets will not show up for a flight. If the airline overbooks a particular flight, what are the chances that they'll have enough seats for the passengers who do show up? A couple plans to have children until they have at least one child of each gender. So, how many children should they expect to have? All of these involve the idea of probability. So in a football game, a coin toss helps determine which team gets the ball first. Why do the rules of football require a coin toss? Because tossing a coin seems a fair way to decide. This is one reason why we would use random samples or randomized experiments. They avoid bias by letting chance decide who gets selected or who receives which treatment. A big fact emerges when we watch coin tosses or the results of random sampling and random assignment closely. So, chance behavior is unpredictable in the short run, but has a regular and predictable pattern in the long run. So, this is going to be the basis for the idea of probability. So we might suspect that a coin has a probability of 0.5 of coming up heads just because the coin has two sides, but we can't be for sure. In fact, spinning a penny on a flat surface rather than tossing a coin gives heads a probability of about 0.5 rather than 0.4. If you think of a thumbtack, they also have two ways of landing, pointing up or pointing down, but the chance that a tossed thumbtack lands point up isn't 0.5. How do we know that? From tossing a thumbtack over and over again. So the probability describes what happens in many trials, and we must actually observe many tosses of a coin to pin down a probability. So here's a little bit of an example to show you like long run versus short run behavior of a coin toss. So when you toss a coin, there are only two possible outcomes, heads or tails. Figure A shows the results of tossing a coin 20 times. For each number of tosses from 1 to 20, we have plotted the proportion of tosses that gave a head. You can see that the proportion of heads starts at 1 on the first toss, falls to 0.5 on the second toss, gives a tail, then rises to 0.67 and then falls to 0.5 and 0.4 as we get 2 or more tails. After that, the proportion of heads continues to fluctuate but never exceeds 0.5 again. So then suppose we keep tossing the coin until we have made 500 tosses. So figure B shows the results. So the proportion of tosses that produce heads is quite variable at first. As we make more and more tosses, however, the proportion of heads gets very close to 0.5 and then it stays there. Okay, so the idea of going from 20 to 500 trials is getting us into the idea of our law of large numbers. So the fact that the proportion of heads in many tosses eventually closes in on 0.5 is kind of guaranteed to us by the law of large numbers. So the law of large numbers is an important result that says if we observe more and more repetitions of any chance process, the proportion of times that a specific outcome occurs approaches a single value. This value is called probability. So the probability of any outcome, and this is much of what you already know about probability. So the probability of any outcome of a chance process is a number between 0 and 1 that describes the proportion of times the outcome would occur in a very long series of repetitions. So probability gives us a language to describe the long-term regularity of a random behavior. So probability of getting a heads in a coin toss is 0.5. So this would kind of be interpreted as it occurs half the time in a very large number of trials. Outcomes that never occur have a result of 0. They're impossible. As opposed to an outcome that happens every repetition has a probability of 1, meaning it's always going to happen. So here's a little bit of an example, and then you guys will have a check your understanding, and then we'll be done. So this is about life insurance and the probability and risk. So how do insurance companies decide how much to charge for life insurance? We can't predict whether a particular person will die in the next year, but the National Center for Health Statistics says that the proportion of men aged 20 to 24 years who die in any one year is very, very small, 0.0015. This is the probability that a randomly selected young man will die next year. For women that age, the probability of death is about 0.0005. If an insurance company sells many policies to people aged 20 to 24, it knows that it will have to pay off next year about 0.15% of the policies sold to the men and about 0.05% of the policies sold to women. Therefore, the company will charge about 3 times more to insure a man because the probability of having to pay is 3 times higher. Okay, so here's a check your understanding. What I would do at this point is read it over, and then I would pause your screen for a little bit, try them out. You can print out my PowerPoint. It's located on the same page as your video. And so you'd have it in front of you. Try it yourself, and I'm going to give you guys a few minutes, and then I'm going to flip to the next slide which will have the answers, and then there's one more question for you before you're done with this video, and that would be the same thing. Pause it, try it, and then check your answers and you'll be done. If you had a hard time with it, I would rewatch the video, make sure that you write down any questions that you have, and other than that, you can expect to see the next video shortly after, and take good notes on that, and good luck.